All right, as we continue on in chapter 4, we get into normal proportions. And in this section, we actually start talking about specific problems on how we can use the normal curve to analyze data and find the proportions. So far, we've just found proportions given the z-score, or we found the z-score and then found the proportion. We're going to actually have word problems where we actually solve it in terms of real-life situations. So, how can I calculate a normal proportion to help analyze data? The process we take is step 1. You take the problem in terms of the observed variable, which we will call x. Okay. Step 2 is draw a picture to show the area under a normal curve. Step 3 is standardize the observations. Of x, so our observations of x, and we will convert them to a z-score. So we actually have to find the z-score again like we have before. Step 4 is draw a picture to show the area under the standard normal curve. And then step 5 is find the required area under the curve using your z-scores. The z-scores would be from our chart. Okay. So if you look at example 1, it says find the normal proportions of the following problems. So step 1, if you look above, is state the problem in terms of the observed variable x. So our step 1 is going to be x equals, and we have to figure out what this is in terms of the problem. So our problem says, what proportion of 800-meter athletes have times less than 120 seconds? If we're given the normal curve is the mean and the standard deviation of 124 and 3.6. So on this one, x is the time of 800-meter athlete. So we determine what x is. Okay, and the time we want to find is the probability that their time, or that x, is less than 120. Okay, we're trying to find out what is the chances, or what is the probability that the time of an 800-meter athlete is less than 120 seconds, given the mean of 124 and standard deviation of 3.6. Step 2. After you define your variable, you define your x, we're going to draw a picture to show the area under a normal curve. So we draw the normal curve. Okay, in the middle of your normal curve, you will put the average, or the mean, which is 124. We want to find out the probability that it's less than 120. So 120 is on the left side of 124. And we want to find out less than that, so we shade to the left. So what are the chances it's in that shaded region? What are the chances it's less than 120? Step 3 is standardize the observation of x by converting it to a z-score. So this would be find z. So z equals the observation minus the average divided by the standard deviation. So in this one, z equals -4 divided by 3.6 is -1.11. So that is our z-score. Step 4, once you find your z-score, step 4 says draw a picture of the area under the normal curve. So now we're drawing a normal curve again. This time in the middle is going to be 0, and we're going to put -1.11 on here. Okay, this is like what we did in section 4.3 where they give us the z-score. You have to find the probability. So basically, we took what we know. We took the 120, and we took the average and the standard deviation and found the z-score. So we're trying to find out what is the probability that z is less than negative 1.11. So in step 5, we're going to find out that probability. So step 5, find the area under the curve using your z-scores. So what we have to do now is use our z-table or z-score table, which I actually have in the bottom here. So we're going to find out the z-score for negative 1.11. So way down here in this table, negative 1.11. So here's negative 1.1. Negative 1.11 is right here, because you use on the top that negative 1.1 and then the 1 is on the top. So it's 0.1335. So the answer is, for step 5, it's 0.1335, which is 13.35%. Half times less than 120 seconds. So basically, by finding that probability in terms of this problem, we found out the probability that running less than 120 seconds in the 800 meter would be about 13.35%. So only about 13.35% of runners would run less than 120 seconds, based on the information from this problem. Okay, let's try number 2. The first step is define your variable in terms of x. So in this one, they tell us what proportion of 800 meter athletes have a time greater than 125. So for step 1, we would just again say x equals time of 800 meter athlete. Okay, and this time I want to find out what is the probability that their time is greater than 125. So what are the chances that they run faster or longer than 125? And again, we have the average and the standard deviation is given. So the probability that x is greater than 125. Step 2 is draw the normal curve. The average goes in the middle, so 125. Sorry, 124, not 125. And 125 is bigger than 124, so that will go on the right side. And we want to find out greater than 125, so we're going to be shaded to the right. Okay, so we're looking for that area to the right of 125. So we'll draw that picture. Next, step 3 is find the z-score. So the z-score is take your observation or your x value minus the mean divided by the standard deviation. So it'll be 125 minus 124 is 1, and 1 divided by 3.6 is 0.28. So that is your z-score. Once you find your z-score, we're going to draw another normal curve. This time 0 goes in the middle, and the z-score is 0.28. So you put that z-score on your normal curve, and again, we're finding what is greater than, we're going to find out the probability that z is greater than 0.28. That's what we're trying to find. The probability that z is greater than 0.28. Because we're trying to find the probability that's greater than 125, and 125 gave us a z-score of 0.28. Step 5 is find the area under the curve using your z-score. So we have to use 0.28 and go down to our table. So 0.28. Positive 0.28. So here's positive 0.2. We have to go all the way over to 8. So 0.20, 0.21, 22, 23, 24, 25, 26, 27. Here is 0.28. 0.6103. Using our table, we got 0.6103. Okay, so what that tells us, 0.6103 is what's to the left of that line. Okay, we want to find out what's to the right of that line, so we have to do 1 minus 0.6103. So we will get 0.3897, which would mean 38.97% have times greater than 125 seconds. Based on what we found there. So using our Z's table, we can find out what percent of people will run longer than 125 seconds in the 800-meter dash. Okay, and we got 2 more that come from number 3. So number 3 is kind of a health one. It says the level of cholesterol in the blood is important because high cholesterol levels may increase the risk of heart disease. The distribution of blood cholesterol levels in a large population of people of the same age and sex is roughly normal. So for 14-year-old boys, the average is 170 milligrams per DL, and the standard deviation is 30 milligrams. Can they tell us that levels above 240 may require medical attention? So if you're a 14-year-old boy, they give us the average and the standard deviation, and they tell us if it's above 240, you could probably have some problems. So we want to find out what percent of 14-year-old boys have more than 240 milligrams per DL of cholesterol. So this is just like we did on the front page. So we want to find out the probability that cholesterol, X is cholesterol, I should put that, X is cholesterol. We want to find out the probability that X is greater than 240. What are the chances that the cholesterol is bigger than 240? Step 2 is draw the normal curve. Okay, the average goes in the middle. The average is 170. 240 is over to the right. And since in step 1 we said we want to find out what's greater than 240, we're going to shade to the right of 240. Okay, find out what is bigger than 240 or what is over to the right. The next step, find the z-score. So take your observation, which is 240, minus the average, which is 170, divided by your standard deviation. So what is 240 minus 70 divided by 30? 240 minus 170 is 70, and 70 divided by 30 is 2.33. So that was step 3. You find your z-score in step 3. Step 4 is draw the normal curve. So this is like saying what is the probability that our z-score is greater than 2.33. So that would mean draw your normal curve. For the z-score, 0 is in the middle. 2.33 will be on the right of that. So we're looking for what is to the right of 2.33 when the z-score is 2.33. So we got to use our table again. So take a second, draw that down, or mark that down. I'm going to slide down to my table and find out the z-score for 2.33. So positive 2.3 is here. So we have 2.30, 2.31, 2.32, and here's 2.33. 0.9901. So the area to the left is 0.9901. So in step 5, to find the shaded region, we have to do 1 minus 0.9901. 1 minus 0.9901 is 0.0099, which means 0.99% have more than 240 milligrams per DL. So this means it's very, very rare. Less than 1% of 14-year-olds have a higher cholesterol than 240. So it's very rare because it's very uncommon for 14-year-olds to have heart issues as well. Okay, part B is the same problem, except for now it's saying what percent of 14-year-old boys have blood cholesterol between 160 and 240? Okay, so step 1 will be we want X to be less than 240 and greater than 160. We want to find the probability of that. What is the probability that X is less than 240 and X is greater than 160? So step 2 will be draw your curve, put the average in the middle. So 160 goes on the left, 240 goes on the right, and now we're shading in between. So what is the probability that it is in between 160 and 240? So when we do this, we actually have to find 2 z-scores for step 3. So we got to find the z-score for 240. So 240 minus 170 divided by 30. We actually just found that. It's 2.33. We found that above. And we got to find the z-score for 160. So it's 160 minus 170 divided by 30. So 160 minus 170 is negative 10, and negative 10 divided by 30 is negative 0.33. So we have 2 z-scores. So we want to find out is what is the probability that the z-score is less than 2.33 and greater than negative 0.33. So what is the probability that the z is in between those two numbers? We draw a normal curve. And for the z-score, 0 goes in the middle. 2.33 and negative 0.33 are the other two numbers. We're shaded in between there. So what is the probability that it's between 2.33 and negative 0.33? So we have to do is look up those two numbers. So let's look up 2.33 0.33 is actually right here. 0.9901. So the bigger one gave us, I'm just going to put in red here, 0.9901. Now we got to look up negative 0.33. So I scroll down here, negative 0.33. Gotta find the negatives. So here's negative 0.3. So 0.30, 0.31, 0.32. Negative 0.33 is 0.3707. 0.3707. Just double check that. Yeah, 0.3707. So I got a slide up here. This was 0.3707. So to find the in between, we take the bigger number, 0.9901, minus the smaller number, 0.3707. Can we subtract them? We get 0.6. What do we get? 0.6190. No, 0.6194. Then we get 0.6194, which would mean 61.94% have levels between 160 and 240 milligrams per DL. So a pretty good chunk of them, pretty good chunk of 14-year-olds have a cholesterol between 160 and 240, 61.94%. All right, and we're going to stop right there. And if you have any questions, I will see you in class.